So here, the way the technological developments is very much depends on the advances in the field of materials. So whatever the product may be, the material is the most important one which plays a major role. So while designing any product, it may be a machine or a computer or even a washing machine or whatever may be. So the material is the selection of material is very important. So based on the based on the temperature, based on the environment, based on the load, so the material selection is very important. So in that, composite is one of the advanced material which is used now in all the uh, means all the parts, irrespective of field. It may be of mechanical or civil or computer science or biomedical, whatever the field may be. The application of composite plays a major role. Uh, so, uh, so means what they're saying, whatever the field may be, the limitation and advancement depends on the material only. So these composite materials are means while optimizing with various materials, so it plays a major role. Means when we compare with, there are many materials are there which starts with metals, alloys, non-metals, semiconductors. So there are many materials. So among if we compare with all the materials, this composite material only will have more properties and strength. Okay. So how this composite material? We are saying it is an advanced material, but the idea behind this material is not a recent or new one. It is based on the nature. So means not alone nature, based on the this composite material concepts started in Egypt. It means in Egypt before Christ BC, so around 2000 BC, the people have started using the composite materials. So now we have did an advancement. That's it. But the concept was started years ago, or decades, or what we can say, more than 100 or 1,000 years ago itself. They have started the using the composite materials. So, so how this composite materials will get unique feature means based on the selection of matrix and reinforcement. So based on that only, they'll this composite, the composite means nothing but it will be made of two materials. One is matrix, another one is reinforcement. So this composite material can be means that the proper whatever the property we need, we can make one composite material according to our requirements. So example, when we need high strength, we can make one composite material. When we need less weight, we can make one composite material. When we need a higher temperature resistance, example, we are launching a rocket which will cross our Earth to outer atmosphere. So that time temperature change will be high. So that time it has to resist. So we can use one material which will resist the temperature. So example, we are your bone is there, your bone getting fractured. You are going to replace that material with composite material. So that should be means biomaterial. Biomaterial means in it has to react with blood. So whatever the property we need, we can introduce, we can develop one composite material. So this is not a means this is not going to end. So it will keep on grow even years change. The material new every day there will be a new material which the designer will use for his purpose. So example, if we are manufacturing using 3D printing, so we can use this composite material. If you are using means a CNC machine, okay, we can go for metal matrix composite. So like that, any based on the manufacturing process, based on the property requirement, we can develop a new material. So this new material is we can call a general term called composite materials. So this composite materials was used in all the applications from before 20 years itself. So now what we are using at present, what we are going means we are going with nano composites, bio composites, hybrid composites. So advancements. So every day the advancements is keep on means developing. So they are the scientists every country have different materials. The example, when if you take example of Malaysia, so the Malaysia will have a rubber plantation is more there. So there, how they are use, how we can use rubber in that composite material. So they will do that researches. So if you take South Africa, African countries, that grasses, that plants, hemp fibers will be more available. Plenty of fibers will be available. So how we can adopt that fibers into this composite? So like that, based on the country, based on the availability of source materials, these composites are getting developed. Okay. So what is a composite? How we can define? There is no general definition for composites till now. But based on the means literature, based on the books, we can say the composite is composed of two or more materials at a microscopic scale and have chemically distinct phases. Okay, so what they are saying is a material which have two or more materials. It can be three or four or five. We can call it as a composite material. And second part, what they are saying, heterogeneous at microscopic scale, but homogeneous at macroscopic scale. So what they are saying is, when we look from our eyes, it will be looking as a single material. But same thing, if you look the same material through microscope, it will be heterogeneous. Means we can able to see how many materials are mixed. Okay, but when you see from eyes, sometimes it is not visible, sometimes it will be visible. Okay, so this is the point they are saying. So what they are saying, when you see through microscope, we can able to see what are the materials present inside the composite. But when you look, example, in metal matrix composite, it is impossible to find what are the materials they have added, but in microscope we can able to see. Okay. So on third point, they are saying constituent materials have significantly different properties. Means whatever material we are adding, so it will have different properties. Example, we are adding two material, both have high strength. Means so there is no use of composite. So it will become more tough and it will break easily. What we have to do when we design a composite, one material is low cost, another material is high cost. So we can compare these two material, we can combine these two material, means we will get medium cost. So same I am saying, one material is low strength, another material have high strength. So when you add this two material, you will get medium strength. So what they are saying, in composite you cannot add two low strength materials or two low cost fiber materials or two high strength. So opposite if you add, means we will get our required property. Okay. So example, we are adding glass and sand. So sand have 5 megapascal, glass have 10 megapascal. So when you mix and find one, develop one composite, means that will have 7 megapascal. So 5, 10, if you combine, you will get 7. So if you combine 5 and 5, means you won't get anything. The constant materials have significantly different properties. So when we can call as a composite, means after mixing of two or three materials, there should be a property change. Means example, if you are adding 5 megapascal and 5 megapascal material, after that also if you get 4 or 5 or whatever maybe, so that is not called as a composite. So after combining two materials, there must be a property change. Then only we can call that as a composite material. So example, you are making one food. Okay. So if you are adding two different kind of material in that food and making. Example, we can. I think you are aware of that kesari. Okay, it is one kind of sweet. So there they will add that two material. One is rava, another one is sugar. So if you add them in a proper mixture only, you will get our flavor taste. If you example, if sugar is not added on the proper quantity, means so that sweet will not be there. So like that they are saying, when you add two material at a proper proportion, so we should not add randomly. So 20%, 30%, that fixed ratio is there. So if you add the two materials, there should be a property change. then only we can call it as a composite. And second point, what they are saying, content of the constituents is generally more than 10 percentage. Otherwise, what we can call you means are you? I think you are aware of alloy. So, in that alloy, we will not add 5 or 10 percentage. Otherwise, we will add only very less amount, 1%, 0.05 percentage. Like that only we will add. Okay, so what they are saying, so we cannot call it alloy as a composite material. So whenever the material you are adding is more than 10 percentage, then only we can call it as a composite. And also what they are saying, property of one constant is much greater than less. So it must be more than 5 percentage. Then only we can call it as a composite. If you add 1%, 2%, 0.5 percentage, so that we cannot call it as a composite. That we can call it as an alloy. Okay. So these are the means formal definition available in the textbooks. But till now there is no proper definition for composite. And same they are saying the composite material can be combined with two or more materials that have quite different properties. Also, what they are saying, the different materials works together to give composite unique properties. So different material means, as I have said, that material should have different properties, not same property. And also what they are saying, the composite, if you see in the microscope, we can able to see easily the materials which is present there. So what they are saying, they do not dissolve or blend into each other. So example, if you simple example I'm saying, if you add sugar or salt in a water, if you mix it means you cannot able to find the sugar or salt even in the microscope also we cannot able to see that solution. But in the composite, whatever you mix and you make a composite, after that in the microscope, the two materials will not mix together. So we can able to see through the microscope. But in alloy or solution, we cannot able to see. Simple, everything this composite you have to imagine practically. So compare when you add a salt with the water, if you mix it, you cannot again find a salt or through microscope if you see also we cannot find it, it gets dissolved. But in case of composite, that materials what we are adding, it never get dissolved, it will be visible through microscope. Just they are comparing with alloy. Okay, so why we need composite material? So you can say there are a lot of materials available. There are a lot of metals. Everything is available. Why we need composites means the only simple answer is enhanced. Enhanced means improved. Improved and desired means what we want. So enhanced desired properties. So if you want high, so steel means you cannot even change the property of steel. If aluminum means you cannot even change the property of aluminum. That remains same. But composite we can change. Example, if with aluminum, if you want to add some property, example, aluminum that wear, it should be wear resistance. We want to make wear resistance means what they will do, they will mix silicon carbide with the aluminum. So if you want, so I want to use aluminum in high temperature application means with aluminum they will mix zirconia. So that will get that can resist the temperature. So like this we can add with the metal or any material. We can add with another material so that the property can be improved. So like this we can improve the strength, we can improve the stiffness, we can improve the toughness, we can improve the corrosion resistance, wear resistance, even we can reduce the weight. So fatigue life, thermal insulation, thermal conductivity, acoustic insulation, energy dissipation, attraction and cost. So these are the main points why we are going for composite materials. And also we can take tailorable properties. Tailorable properties is only for composite materials, not for metals or any other conventional materials. So tailorable means whatever we want, we can make. So if you want to increase strength, you can make. If you want to increase the stiffness, you can make. If you want to increase the toughness, we can. If you want to increase the corrosion resistance, we can. So that is called tailorable mechanical properties. So tailorable properties means we can change the property of the material based on our requirements. Okay. And if you see why we are going for composite materials, so see the simple example of an aeroplane. So the wing span is there. So these two wings should be stiff. So the first image of this means wing is the original one we mark. So you see the second, and if you put the low strength material, if you put any material which has example tin, you made this wings with the tin means so it will bend while flying. That aerodynamics while it's flying, the one wing gets it will get bent. So you that flight immediately it will get failure and it will means it will explode. So third one you see that if you use a material which will have less fracture toughness, the material which have less fracture toughness, it will break into pieces. Okay, so if you use the fourth image, if you use the heavy weight example, if you use steel, so it will not take off because of the more weight. So while choosing a material for this wing blades, we have to see the material which should have higher strength, higher fracture toughness. Also, it should be lighter. So that's why they will use. Anyone know which material they are using for the wings? So nowadays they are using composites, but earlier they used dura alum. So entire most of the material for this aeroplane is made of dura alum. So one type of an alloy. So we cannot use a single material for aeroplane. So like this, based on the so now here you have to choose. So earlier they tried with one material they tried different types of failures they got. So after that only they found one material which satisfies all the properties. So this is one simple example for application. If you want to choose a material for a wing, so you have to see a material with higher strength, higher fracture toughness, and lightweight. So these three property if it satisfies, then it will that flight will take off. If even if it will not satisfy one property also, so the flight will not take off. Otherwise, it will explode. Okay, so there we go for composite materials. Nowadays, completely and 90 percentage of the around 80 percentage of the weight of the aeroplane is fully made of composite materials. So that's why we can the means we when the weight we reduce the weight based on the composite material. So automatically the fuel consumption got reduced. So if the fuel got reduced, the cost of the tickets got reduced. That's why today we can fly from Chennai to Singapore at 5,000 rupees. But if you are not using composite materials, if you use metal means it will be around 20,000 per person. Nowadays, if it is very cheap, the flight cost is very cheap. We can travel 5,000 kilometers for 5,000 rupees means this it is purely based on composite material only. Earlier also they used white petrol. Today also they are using white petrol. So the fuel doesn't get changed even till now. But based on the material, they one by one they reduced. Earlier they started with 20% reduction, 30 percentage reduction. Like that, now they are using 80 percentage reduction, 80 percentage composite they are using, 20 percentage metal alloys they are using. So that the complete weight got reduced and fuel consumption got reduced. So that ultimately the cost got reduced. So same you can take example of this two wheelers. So one is TVS XL, which will come around the overall weight of 88 kg. It will give mileage of 55 kilometer per hour per liter. But same if you take Royal Enfield, it is of 195 kgs weight, but it will give mileage of 37 kilometer per liter. So what we can decide from these two vehicles? So when the weight get increased, the mileage get reduced. Okay, so our ultimate aim is to reduce the weight of the vehicle. So if you reduce the weight of the vehicle, the fuel consumption will be less and you will get more mileage. So that's why if you compare the today's car with the olden days ambassador, the ambassador will have more weight. It is made of stiffer material, so it will not give mileage itself. So, but we cannot go over speed also. It will go at an average speed, and the mileage also it will give less. But today, if you take any of the cars, completely it is made up of means composites. So that's why means your our mileage also get increased. The cost of the car also got reduced somewhat, not more. Somewhat the cost also reduced. But the only thing is the earlier materials will absorb the energy, impact energy, and it will transfer to the passenger. So car will not get damaged, passenger will get damaged. But nowadays car will get damaged, passenger will escape with minor injuries. Your life will be saved. So this is the revolution which have happened, which is used to save the life. So what they are saying, they are reducing the weight at the same time it means it will reduce the fuel consumption, and also when the automatically what happens when the fuel get reduced, fuel usage get reduced, that environment pollution also get reduced. So that's why the most of the now the European regulations have made a means a strong point that it should be made up of composite materials instead of that metal alloys. So what they're saying, so 10 percentage if you reduce weight means your fuel consumption will reduce about 7 percentage. So that when the vehicle weight is reduced, we can save more fuel. So why we want to make new material? So first condition is to reduce the weight, and also to increase the fuel economy, means reduce the fuel amount. Automatically it will reduce the pollution. But at the same time, whatever the metal alloys which gives mechanical properties, same our composite also gives. So without compromising the mechanical properties, only weight should be reduced, but the property we should get the same. So like that we have to design a new material. Okay. So why we need FRP means fiber reinforced polymer composites in the aeroplane. So same they are saying statistically report they are giving. So if you reduce 0.453 kg in an aircraft, see imagine at least means I mean 0.453 kg means 500 grams. So if you reduce 500 grams, 1,360 liters of fuel per year we can save. That means 25 percentage of the operating cost we can say. Imagine only nothing they are doing, only they are reducing the weight of the vehicle. So if they are replacing dura aluminum with composite, carbon fiber composite means 500 grams if you reduce 1,360 liters of fuel we can save. Imagine now they have reduced about 200 kgs to 300 kgs they have reduced. So then how much fuel they can save nowadays? So that's why the composite materials plays a major role in any of the applications. Which first it will first it will reduce the weight. Next it will give a improved property. So many things. So like that they have given us the statistical report which will which will give more property. So earlier they used composite, but that material is not a fire resistant material. So 15,000 people have lost their lives. Why? The material they have used is not a fire resistant. So nowadays everything they improved. So nowadays whatever their material using, it is fire resistance only. So they used polymer composites to earlier they used metal matrix. Now they are using polymer matrix to reduce the fire resistance, increase the fire resistance property. So what we are going to get if we make composite? So first addition of properties. If you add glass is A, polyester is B. So if you add glass and polyester, you will get a C material, which is glass fiber reinforced polymer. So glass will have high strength. Polyester is of chemical resistance. So what we will get high strength chemical resistance material. So earlier, imagine when glass alone is used means it will have strength, but it won't have chemical resistance. If you use polyester alone means it will have chemical resistance, but it will not have high strength. So when you mix the two, you are getting GRP. So the best example we can say for composite is concrete. When you use only the sand, nothing you will get. When you use only the gravels, nothing you will get. When you use only cement, nothing. When you use only steel bars, nothing. So when you mix all these only, you will get a strong pillar like that. So like that, each material will have different properties. When you add it together only, you will get the combined property. So that only we can call it as a composite. We cannot call this glass as a composite. We cannot call polyester as a composite. But together when we mix, we can call as a GRP as a composite material. Also unique properties. So glass is also a strong material and polyester is also a strong brittle material. So when you get combined both, so you will get that tough material. Okay. So like that properties also will change. Okay. Mechanical properties also will change. So this you see this as a temperature. So in y-axis they have given temperature 200 degree, 400 degree, 600, 800 to 2000 degrees Celsius. See here they have compared different composites. So earlier they used polymer composites and they checked the polymer composites around 500 degrees Celsius it can withstand. Then they tried with metal matrix composites. The metal matrix composites withstood around 1100 degrees Celsius. Then they tried ceramic matrix composites. So it withstand around 1500 degrees Celsius. Then they went for carbon or graphite. Both are carbon composites. So it withstand about 2000 degrees Celsius. So like that the evolution have happened year by year. People of different materials they have compared with the all other old materials. At last now that carbon fiber composite is the material which will used for space application. Otherwise, where you have high temperature, if you want to withstand 2000 degrees Celsius means there you can use this carbon composites. So example we can say in power plants when the person want to resist for fire, they will use the cloth which is made up of carbon fiber. So they will that fire will not affect them. So like that, where you want to withstand the temperature, there you will have this composite material. So what are the special features this composite material have? Means first one is good specific strength. The strength we know what is meant by specific strength. So when you compare the strength in means of weight, then we can call it as a specific strength. So strength to weight ratio. These composite materials will have 40 to 60 percentage more strength to weight ratio than the aluminium. So among the all metals, aluminium only will have highest specific strength, but this composite will have 40 to 60 percentage more than aluminium. Okay, and corrosion resistance. Corrosion resistant means, so example, you are using one vessel which is prone to this acids. So what will happen after 5 to 6 times usage? It will get rust. The corrosion will happen. So these composite materials are will never get corroded. So how many times if you use also it never get corroded. That is also one of the main any chemical you use you will not get corrosion. But even if you use metal or alloy, definitely corrosion will be there. But in composite, you never get corrosion. The specific strength is more and durability. So life of the so automatically when the metal and alloy gets corrosion, the life will get means easily will erode. But in case of composite, there is no erosion. So the durability is more. So the life of the material will be more. That's why they are replacing means metals with composites. And also cost of the composite is means quite high, but nowadays it is getting reduced. Earlier when we used composites during our BTech, 1 square meter of carbon fiber cost 8,000 rupees. But nowadays same if now we are using for our students, it is 2,000 to 3,000 rupees. So based on the development, based on the more production quantity, nowadays the composite cost is getting reduced. And the other point is high specific modulus. So specific modulus means ratio of Young's modulus to the density. So this is also very high for composite material. What means so we can use the cross section area and mass very less when compared to the metals. So this is the fifth property for composite material. So this is some of the properties which they compared with the use. So earlier they used steel more in every places. Why? Because it is very the cost is very less. Next they used aluminium. So after so steel and aluminium are the most metals which any product you take, either it will be made of aluminium or a steel. So nowadays all these parts are made of completely, they are made with composites. If you take example of washing machine, earlier the complete component is made with some metal alloys, lightweight metal alloys. But nowadays, if you touch that, it will be composite material. Even if you touch means that based on the sound itself, we can able to see that. So like that, earlier they used the steel chairs in all homes. Nowadays they are using polymer composite chairs. So like that, the way why main thing is weight. So when you compare steel, aluminum with composite, the composite will have very less weight than the aluminium. And thermal expansion. Thermal expansion means when you heat, that material should not expand. If it get expanded, the property will, the strength will get reduced. For example, if you see, if you melt the steel or aluminum, any metal, it will get bent. But that means it is expanding due to heat. But composite will never get thermal expansion, even 1% also. So the thermal expansion is very less for composite. And specific stiffness. So if stiffness means when you bend steel means, if you apply more force, the steel rods will get bent. Same aluminium, if you spend less force itself, aluminium will bend. But composites, it will not bend. It even example, I am making a small aluminium rod means, even elephant stands on the rod also, it never bend or break. That much strength and stiffness the composite material will have. Same if you take a same weight, same property of aluminium or steel means, it will get deformed immediately. But composite will not get that much deformation. And strength also, it is more when you compare with the metals. Okay, so the composite will have more strength. These are the four main properties in which the designers and engineers chosen composites and replaced all the metals and alloys. Okay, so, and in that, as I have said, simply only one term I am using, nano composites. So, composites is a material which they have used more than 100 years ago, but nowadays, recent 2020, from 2010 to 2020, everyone is working on nano composites. So, this simply only one example I am giving. So, means the effect of nano composites I am saying, how to use the material effectively. So a simple practical example, you can keep it in your mind to remember this nano composite is, yeah, buttermilk. So if you take a tumbler of buttermilk, 100 ml, so imagine you are putting one green chili in that and mixing it. Full green chili, what you are buying from shop, directly you are adding the green chili in that buttermilk, you are mixing it. And if you drink means, means 95% you never get the taste of the chili. You will get the taste of the buttermilk, but you won't get the taste of the chili. And imagine that is macro level. And micro level means you are cutting the same chili into 10 pieces. Now you are mixing with the buttermilk, you are mixing and you drink. Now 60% we can able to bear the chili smell. Same chili you grind in the mixie and means powder. So powder is mixie, you grind it and add in the buttermilk. Now if you drink, 100% of the chili property you will get. The same this nanomaterial, when the size of the material get reduced, the property of the material will get more. So means when 10 power minus 9 meter is nano. So when you use that material, when the size of the material get reduced, the property of the material gets more effective. This example you can keep it in the main for nanomaterial. So the main drawback for the nanomaterial is agglomerate. So when you add the material, when you add the powder in the, say example, if you take a milk powder instead of milk, if you want to make a coffee or a tea, you are using instead of milk, you are using milk powder. So when what we will do, so when while cooking we will use hot water first. In that hot water we will put the milk powder. So when you put milk powder, it will get into round round balls. We can able to see. When you try, you can see. So round round balls it will come. That is called agglomeration. Agglomeration means, so when you mix some powder with the liquid, so it will not get mixed properly. So you have to stir more time. Then only it will get mixing. So this is the main drawback of the nano composite. So this is the composite which they are using at present. In whatever application we want, they are trying only nano composites. Even some cloths are there which is made of nano material. So means by based on the sunlight itself, it will get automatically washed. No need to wash. And same time, some best example is, we can say that raincoats. Even the water falls on the raincoat also. It will not stick on it. It will easily drop from that. So like that, nano material they are applying in all the areas now. So when you add any nanomaterial in the composite, that is called nano composite. And another thing which they are using recently is biocomposite. Uh, biocomposite means what means? So we are using any biomaterial. So biomaterial means which will withstand this blood, which will withstand the human means bone. So everything which is keeping inside the body, then we can call it as a biomaterial. These biomaterial can be added to any composites, then we can call it as a biocomposites. So where they are using this biocomposites? So when joint replacements, so when two joints are means in a human body, when two joints are get damaged, so to join that they are using biomaterials, bone plates. So earlier we can able to see in movies also, because when bone got fractured, they might have keep the steel plates inside. After that, they kept titanium plates. These titanium plates, what happened means, it is a metal. Titanium is a metal. So after 5 years, when your bone gets joined, it will get itching. So it cannot withstand that our blood circulation, and it will give more pain to you. So what they will do? Immediately they will make a surgery. So they will make a surgery and they will remove the joint. Okay. Nowadays it is not at all required again for a second surgery. So we can use biocomposites in that. What it will do after five? So its lifetime will be 5 years. So when the bone got joined, after 5 years it will get degradable. So inside the blood, that blood circulation, it will get into it will not get. Earlier you can say stitches they will make. So after they will say after 10 days come, we have to remove the stitches. But nowadays they are using biomaterial for the thread. So that thread, what it will do after 1 year, after 10 days, it will get it will get decomposed. So no need to do another time removal. So like this dental implants. So example, your teeth got damaged. Earlier days means before 30 or 40 years, if your teeth get damaged, front side, what they will do? They will replace the teeth with gold. So after that, they use the silver to replacement. Nowadays, same calcium composites we can use, and we can replace the teeth. Okay, same like that earlier blood vessel processes. Earlier, if your blood vessel get damaged, what they will do, in from the leg they will remove the one extra blood vessel. They will put it in here in the heart side. But nowadays, no need to remove any vessel. So we can create one new bio vessel. Then we can use that heart valves. So earlier, what they will do, transplantation they will do. They will take from some other person valves. Then they will keep. Nowadays, no need. We can create artificial walls using 3D printing, using biomaterials. And skin repair. So like that, contact lenses. So more this earlier contact lenses will be of glass. So someone, if they forcefully hit, means the glass get damaged inside your eye, and your eye will get completely damaged. Nowadays it is flexible. So those who are using contact lenses can know. If you touch, means it will flexible. That means it is made up of polymer composites. So if you keep in your eye, so it will be flexible. Even anyone kids also, we can remove that. Some itching sensation will be there. Within a day you will get all right. It will not get into, it will not break. But earlier they used, glasses. It will get damaged, and so this is the biomed. So biocomposites also nowadays it is getting more, very much, that scope is there for biocomposites. Why? Because this human body, every part they are completely replacing. Even heart of our human heart also we can make using 3D printing. So 3D printing means it is a development in the manufacturing, but material we have to look for different ones. So that's why we are going for biomaterials. So this is also one of the advanced composite biocomposite material. So this is the evolution of materials from 10,000 BC. So earlier in 10,000 BC, first they have used gold. So next they have used copper. So bronze, iron. So we can in our schooling we have studied about the evolution of materials like Stone Age, Bronze Age, Metal Age. Means nowadays we are in Silicon Age. So like this, the ages, the evolution of materials, when the human got developed, this material also got developed. So like that, when it started from gold, copper, bronze, iron, then cast iron they have used, steels they have used, then alloy steels they have used, then super alloys they have used, then titanium alloys they have used. So like that, they have keep on developing. So like that only composites also from 10,000 BC. So composites, natural fiber composites, then man-made composites, then hybrid composites, then nano composites. So like that, when the years reduced, these composites also got developed. So from 10,000 BC, the composite started its growth till 2020. It is still keep on growing. Nowadays, there is no growth in the individual metals. So copper, there is no development. Bronze, there is no development. Iron, there is no development. But this composite from 10,000 BC, still now it is getting development. Okay, so this is the evolution of materials. So I'm not going to discuss deeply this. So next, so as we said, the composites which have evaluated. So what they have did means, so earlier days to create a weapon, first 4000 BC they used writing material. So in movies we might have noticed. So they will insert that one bird feather in one liquid, then they will write. That liquid is made up of papyrus plant. So 4000 BC itself they have used papyrus plant mixing with these two things, their writing material. So then 1300 BC they used straw bricks. So straw bricks means they used grass with the clay. They combined both and they used. Then later 1200 AD the Mongols used bow, composite bow. So we will see how they are making this composite bow. See what materials they used to make composite bow. They have used wood. So wood they have used, horns they have used, leathers they have used, bamboo they have used, and deer horn they have used. So this horn and antler they are using for naturally flexible and resilient. So the bow should be flexible. Okay. So they use this horn and antler, and they use the sinews. So this one part they made using sinews, that is made up of cows and deer tendons and glue. So bladder of fish. So they will cut the fish and they'll take the bladder for sticking. So to stick the two wood, today we are using fevicol. So earlier they used bladder of fish. They used as a glue, and strings that in the bow strings will be there. No, so they used horse hair. Otherwise they used silk they used. So these are the materials they use. So to make a bow, it will take 1 year. So to make a complete bow, so that much time it will take to set. So everything it should be strong, no? So if it is wet means again it will break. So to make a strong bow, that it took 1 year for them. When it in 3000 BC. See, this is the bow, which different kinds of bow they developed using everything they used natural materials. They combined 2 to 3 materials. They developed composites in the 3000 BC. And some of the example is straw bricks, concrete. Wood, if you say our tree is there, no, if you cut the tree, there will be cellulose and lignin. So this is the best example for natural composite. Our human body also, muscle and bones are made of, so muscles is one different type of material and bones are of different types of materials. So this also one type of composite. Then tires, if you see tire, there are if you burn the tire, you can see steel fibers inside the rubber tire. If you burn the rubber tire, you can see that steel fibers. So tire is also one of the example of composite. Then plywood, so from 2 to 3 wood material only they are making plywoods. Then sports material also they are using. If you take a cricket bat, that bat will be of one material and handle will be of different material. So both they would use some gluing agent and they will make the bat. If you take a shuttle bat, that net is made up of different material. That outer covering is made up of different material. So like that, most of the sports good also it is made up of different. If you take a football, outside one material cloth will be there, but inside rubber will be there. Rubber ball will be there. There only you are blowing air. So like that, all products if you take, the composite is employed everywhere. Okay. So this is the best natural example for composites is wood and bone. So the means these both will have mineral salts, collagen, water, like that. Different types of materials are added in bone and wood. This is a wood. So wood also a best example for composite, which will have cellulose and lignin. And brick. So see the bricks color itself. One is red, one is black, and in between they use the cement. So these bricks also they will use two to three different. If you go and visit the manufacturing sites, you can able to see they never use only clay. They will add some other components to get some strength. So then only then they will burn it. Then only we can able to get the brick. So this also one best example for composites. And you might have seen the sea shells. So the sea shells also a good example for natural composites. In which the calcium carbonate will be more. So these from these shells we can make a teeth. So dental applications we can use. So it is very more stronger. These she cells. These are all which is available naturally as a composite material, which is not made by man. Everything is available naturally, which will have a combination of 2 or 3 materials. So later only they developed man-made composites during the World War II. So for military applications, for rocket applications, they used means to reduce the weight. They have used the man-made polymer composites during World War II. This already. So what? So now we can see. So I was saying if you combine matrix and reinforcement, you will get a composite. So this is an just schematic diagram. So matrix will be see how continuously it is. The matrix will be continuously. If you imagine means it will be like a gum glue. If you see, so that gum that is matrix. So reinforcement will be like a nothing but our means jute fibers. So we can use mats, house-made mats. We can see we will use in the house. So like that it will be. So when you combine both means you will get a composite plate. So this is an composite. See, so when you combine this matrix and the fiber, so that interface, so it will get mixing, no? So as I said, it will not mix it together. So it will mix like that. So it will form a bonding. So it will form one new bonding. That bonding only makes the material very strong. Okay. See, so the constituents of composite, which are saying matrix and reinforcement. So what? So here we can see that the light color is there, no? So that is matrix, and center one dark color is fiber. So in between one hatched parts are there. That is the interface which is formed. Okay. So clearly they have given. So like this only the composite will develop. So even though if you mix 2 or 3 materials, it will not completely dissolve in that matrix. So we can, this is a microscopic view. So if you see a microscope, this composite will look like this only. So we can able to see a matrix, we can able to see a reinforcement, and also we can able to see a interface, that is boundary. So three we can able to see. So example for composite. So if you see, if you, that mixing of lignin and cellulose is wood, so that is one composite. Gravel and cement is concrete, so that is composite. But same we cannot say hypertectile steel. When you mix ferrite and perlite, so it will never, it will not be composite. Why? It will get mixing. So it will get dissolved. So we cannot able to see. So we cannot call it this steel as a composite. Then reinforced concrete, gravel plus cement and steel also, it is composite. Then steel, stainless steel, no. If you mix any material, the grains will get moved. So that also we cannot call it as a composite. And cement, no, the cement is not a composite. When it mixes with some material and makes concrete only, then we can call it as a concrete. Sorry, cement, composite. And cellophane, we can call it as a composite. Why? Because the multiple polymeric, different layers, polymeric layers will be there. So we can call it as a composite. Reinforced plastic, even though means that plastic will have different material, but it will not improve the property. So we cannot call it as a composite. So you, in earlier days you have studied paper also. We will, they will mix more materials and they will make paper. We call it as a composite? No. Why? Because only cellulose they will use in the composite paper. So we cannot call it as a composite. Simple example how which is composite, which is not a composite. You can understand from this. So, so based on the composite, so yeah, development was there. When it is a composite, if you call it is a material. So if it is applied to any part, it is called a composite structure. So like this, composite structure are there. Only composite they have used, and they used foam. That is called a sandwich. So example, you know, everyone knows about sandwich. So to, if you take a food sandwich, so top and bottom layers will be bread, and inside they will keep some stuffs and vegetables like this. So like this only this composite sandwich structure we can make. So outer and top and bottom we can use same material, and inside we can use different material. That is sandwich structure. Then honeycomb structure. So top and bottom we will use on plates, and inside structure will be honeycomb. So that will be more reduction of weight and increased strength. So like the different based on the structure, we can change the composite applications also. So this is the main thing. So there are in our world or in our universe, there are only five materials are there. One is metal, another one is polymer, another one is natural materials, foams and ceramics. So if you combine any two, then we can call it as a composite. So either if you combine metal and polymer, then it is composite. When you combine ceramic and metals, then it is a composite. When you combine foams and glasses, so any two if you combine, so this these five types of materials only available in our universe. So if you combine any two, then it is called composites. Okay. So how to make a composite is the biggest challenge. Why? Because so when you mix the two materials, first it should get mixed. It should get example, when you mix salt with water, it will get dissolved. When you mix sugar with water, it will get dissolved. Same if you mix this wax with this material, water, it never get mixed. Like this only composite also. So it never get mixed. So we have to see which is getting more bonding. Okay, which so example, if you want to make one shape, complicated shape, which manufacturing process we can make. So 3D printing is used last 20 years, but earlier we cannot use composites. But nowadays we can use composites in 3D printing. So that's why. So how, which manufacturing process, which material, how we can randomly we cannot combine. For example, if you take biryani, there are varieties of biryani are there. 50 varieties are there. How they are making biryanis by varieties? By changing the ingredients. So, example, if it is more spicy, it is called Hyderabadi biryani. When it is more sweet, it is called Kerala biryani. When it is average, so it is called Tamil Nadu biryani. So like that, same this composite also. So when you mix different materials, we will get different property. So which material we will, so Andhra people will not eat Kerala biryani. So why? Because it will be sweet. So they never like sweet. So they like that means which property we need, that material we have to add. Then only we will get the property. So like that we can produce n number of combinations using this material based on our requirements. So that is the beauty of composites. So what if you want less weight, we can make it. If you want increase the weight, also it is possible. If you want to means increase the strength, it is possible. So the design factors are very important while making a composite. So which factors involve? So which apply? So first example, you are working now. You are a student, so you are just learning about composites. You never think of it. See, when you will think of composites, when you are working, your team leader will call you. Our customer needs this product, which should not be which should be fire resistance, which should be waterproof, which should not get fracture, which should be more durable, which should be less weight. Identify one material, they will say. So then only the headache starts for you. So you have to check all the properties. Which material will have differ? Okay, why can't we go for this material? Why can't we go for? So example, you take a phone mobile covers. It means rubber cover is there, polymer cover is there, metal cover is there. Many different types of covers are there. So everything is on engineer's idea. So if you use this, it will be more lightweight. If you use this, it will be flexible. It will use this, it will be more life. So like that, every product you can change the material. So when you work in one project, means then only first thing is the selection of material. Then only selection of geometry, etc., etc. So that is very challenging when you design a composite. It is very challenging thing to decide the material, which material we can add, which how much percentage we can add. So that is the main thing we have to decide. We have to work on it. We have to select it. Okay. So what they are doing? So as we said, composite means combination of fiber and matrix. So what this fiber will have, the high strength it will have, high stiffness, and also weight is less. Here matrix, it will have good shear properties, low density. So when you mix both, see this is a composite will be like this. This is microscopic view. So if you add these two material, it will look like this in the microscope. So what it will have, combination of two these five properties combines and we are getting four properties. But when you take this matrix alone, you never get this property of A. When you get, if you see property A, you never get property of B. So A plus B, you will get property of C. So easily we can know the formula. So the formula for composite is C is equal to A plus B. But not every time. So all the times it won't be same like that. Sometimes it will get A plus B is equal to C and also D. One new property will be formed when you mix these two materials. That also is possible. So we can get more material, more properties in the composite, but unique material we will get only very less properties. So same we are saying the reinforcement will be discontinuous, but matrix will be continuous. So when you mix both, you will get a continuous material. So what that reinforcement will do? So it will contribute. The reinforcement will improve the property, and also it will carry the load and carry the load, and it will transfer to the matrix. So these are the this is the work of the reinforcement material. The reinforcement material, why we are adding, the property will get improved, it will carry the load, it will transfer the strength to the matrix. And what matrix will do, the matrix will combine the fibers, whatever fiber we are using, that it will combine. And also from the that fiber example, if you take the mats, house mats we will use, no. So that mat, if you water, if you pour water, it will get wet. That means it will absorb water. Imagine that if you fill that mat with the matrix, that epoxy matrix means it is resistant to water. The water it will not absorb, so it will protect the fiber from the environment. Okay, and abrasion, scratches will not happen to the fiber, and completely equally it will distribute the load everything to the within the fibers. Yes. Okay, and also it will distribute the load evenly. So when you use a composite, the load should be evenly distributed. Sometimes in some area it will be more, some area it will be less. Like that it should not be. So it should be uniformly distributed. Okay, and it should have impact resistance and better product finish. So these are the functions of a matrix. Okay, and what property a matrix should have, which property? So first property is it should not be absorbed to moisture. So either it is a steam or means any water or chemicals, so it should not absorb it, and low shrinkage and low coefficient of thermal expansion. So when it is made to heat temperature also, that it should be more, and also high strength. Okay, and the low temperature capability and the excellent chemical. So these are the main properties a matrix should have. And what this fiber will do? So this fiber will the fiber is an reinforcement which will improve the property. So mostly example a composite will have matrix and fiber means 70 to 90% of the load will be carried by this fiber only. So while choosing the reinforcement, we have to be very careful. Okay, and also to provide stiffness, strength, everything this fiber only will do. That matrix is simply to transfer the load and to protect the fiber from the environment. And what are the properties it should have? It should have basic mechanical properties and interface properties, and we should see fiber volume fractions. Means in the composite how much fiber should be used, how much matrix should be used. So that fraction we should see. And also direction, orientation means direction, so horizontal or vertical or 45-degree. So the direction also plays a major role. Okay, see, these are the different types of fibers. So one dimensional, two-dimensional, and nowadays they are using three-dimensional also. So if you take a cloth, that is the best example for a fiber. So even if the different types of weaving are there, if you weave in a different way, the strength will get different. So like that, these different types of fibers are there. See, so this is a unidirectional fiber. That means one direction fiber will be there. In horizontal direction, thread will be there. But bidirectional fiber means two directions fiber will be there. In unidirectional fiber, only in tensile directions the properties will be more. But in bidirectional, both sides property will be more. Example, when you are pulling unidirectional fiber means in horizontal direction strength will be very less, but in bidirectional, even if you pull vertically or horizontally, the strength will be more. How we classify these composite materials? So this detailed classification of composite materials will be explained by Mr. Nagarjuna in tomorrow's session. But just I'm giving how these composites are classified. Only one slide. So based on the make, so how we are making. So either example, if you take seashell, so in nature itself it is made of composites. So then it is natural composite. Example, wood. So we are not doing anything. In nature itself, it is made up of composites. So that are called natural composites. When you make composites, example so we are mixing two or three materials. So like this, if a man made composite, then it is man made composite. So nowadays 90% we are using only man-made composites and based on reinforcement size. So if a size is visible, it can be touched. By touch itself, we can see literally means that is macro. When you see a microscope, that is micro composite. When you see even there are advanced microscopes are there, scanning electron microscope, transmission electron microscope. So that is nano composite. So based on fibers also we can classify. There are particle reinforced composites, fiber reinforced composites, laminar composites, flake composite structure. So which these will be explained in detail uh, in tomorrow session. And these are the composites. So which we use. So when you compare, when you add metals with reinforcement, then it is metal matrix composite. When you use ceramic with reinforcement, ceramic matrix composite. When you use polymer matrix composite, so that is so these are the three main composites which is used for the past 10 years. These three composites they are using. Past 10 years they everywhere these composites gets applied. Okay, so based on the matrix, there are only three classifications. See, what is the difference between failure in matrix, sorry, metal and composite? So this is a stress strain diagram of a metal. That green color is stress strain metal, stress strain curve of a metal. So that means you will get yield strength, ultimate, then only fracture. So that failure is called ductile failure. So example in strength of materials lab, you might have did a tensile test. So steel rod, you will pull, you will apply load in one direction. So when where it is going to get fracture, before 2 or 3 seconds we can able to see neck will be formed. So so we can say, there only the failure will occur. But composite is a brittle material. Suddenly it will break. So there will not be there won't be yield stress. There won't be ultimate. Directly fracture will come. So that is brittle fracture. So yeah, metal will not give composite property and a composite will not give metal property. So when we combine both, so we will get one new property. Okay. So see this brittle fracture. Glass you imagine. When you same instead of steel rod, you are using glass rod and pulling means you never get a yield stress or a compound structure. Directly fracture will occur. So that is all composites are made of brittle fracture and all metals are made of ductile fracture. Okay, this is the main difference you can say between a composite and a normal metal. So what are the various advantages of composites using the conventional material? Conventional material means metals, otherwise polymers. So as I said, no, five materials: foams, metals, polymers. So these are all conventional materials. If you mix this conventional material, you will get composites. So what you will get? First thing is high strength to weight ratio. That means weight will get reduced, strength will get increased. Low density means that weight reduction only. Easy of molding to complex shape. So any material, if you want any shape, if you want, first you have to make a mold. Based on the mold, you can make a product. And this is of non-magnetic. So even if you can, example, you cannot use magnetic material anywhere. Easily it will attract the other metals. But this is composites, it never attract magnetic. And good resistance to corrosion. So any chemicals you can use, nothing will happen to the composite material. Good resistance fatigue means, so due to fatigue means, best example for fatigue load is our fan. So repeatedly load will get applied. So when you applied, so it never get damaged. So good fatigue resistance. High beam stiffness means it never get bend. Strong it will be. Example, if you see that wires, so if a bird sits on the wire means it will get a means it will get. But this composite will not get that much flexibility. So it will be stiff. So thermal means temperature resistance. Even 100, 200 degrees Celsius also, it never get damage. So best example I will say, everyone, I'm thinking that everyone is aware of black box. The black box is a material, I mean a product which is there, which is available in all the aircrafts. So even the aircraft explodes that black box will not get any damage. Safely it will be means thrown where the aeroplane got exploded. So that is made, that is thermal stability. Means even that 2000 3000 degree heat develops also, it will not get anything. So it will never get damage. That is good thermal stability. Good surface maintenance means that if example, if steel your car structure is there, if you scratch means it will get scratched, but when you use composite means that scratches won't happen. That is good surface finish. So good fatigue resistance, high strength, high stiffness. So these are the reasons why we want to go for composites, uh, which cannot be given by the conventional materials. And wherever advantages are there, definitely the disadvantages will be there. So the disadvantage is high cost of raw materials and fabrication method. So example, if you take our mechanical manufacturing, the target will be based on number of pieces manufactured. In all the manufacturing companies, they will have a target 1,000 pieces per hour. But this to fabricate a composite, it will take more time. We cannot produce more composite products in a less time. So that is a main drawback. And cost of raw materials is too high. Metal means only one material we are going to buy, but composite means two or three material we want to buy. Then only we can mix. So definitely the cost will be very high. And also composites are brittle. Brittle means metal means it will get first. So immediately that damage will not occur. First it will get bent, it will get damaged. Then only the cracks will occur. But in case of composite, directly it will fracture only, brittle. And transverse properties means when the load is applied in a vertically, horizontally, that the transverse properties will be very less. And matrix will have low toughness. So that is also one of the drawback. And reuse and disposal may be difficult. Example, aluminium means what they, so aluminum tins we are using. So after usage, what they will do, they will again reuse. They will melt again. They will make another product. You, but same like that, we can example. Are you aware that in olden days the milk was delivered only in the bottles, but nowadays they are using reusable polymer plastics. Okay, but what they are saying, even after 10 years, if you dig also, that plastic will not get decomposed. So reuse and disposal is the same. That bottles we can reuse. What they will do again, when the person comes for next day, he will take the used bottle and he will go. They will sterilize that means bottle, and they will reuse it. Same that syringe in hospitals. When I was in childhood, they will use that glass syringe only. So what they will do when it is used for one person, they will put it in hot water. Again, they will reuse it. But nowadays, these polymer disposable syringes, if they use one time, they have to throw it out. That cannot be used for another person. So disposal is, so one day how many people are, so imagine now corona time, if how many injections they are putting. So per day thousands disposable syringes we are using. So if it is olden time, 5 to 10 we can maintain, then sterilize, then again reuse it. So these polymer material reuse and disposal is very important. That's next point is that health hazards. So means that where they are using making composites, they will get more diseases. So that is a main parts. Joining to parts. Example, if you are making one composite part which can be fixed to a metal means that joining is impossible. So there are more advanced methods are there. So the joining to parts is very difficult. And repair. So repair means what? So if it is made of one material means it is easily can be repaired. But since composite is made of different material, so the repairing is a very difficult thing. And curing takes time means immediately when you, say example, I ask you to manufacture one product in late means within half an hour you will manufacture and immediately it can come for use. But this composite you will take 24 hours curing time. So after that only it can be used. So that curing process will take more time. And analysis. So if you are analyzing any parts, any metal parts in software, it is very easy. But same composites to analyze, it's very difficult since the property in different directions is different. Okay, and environmental degradation. As I said, when you dig the hole and bury the composites, after 10 years also it never get decomposed. It will be same. So that is very means cause damage to the environment. And what are the factors which affects the properties of the composites? So example, distribution. So it is not properly distributed. The reinforcement is not properly distributed means, so it will reduce the property. You won't get the correct property. So concentration means percentage. So if five instead of 5%, if we add 50% and make composite means, then you won't get the property. So same orientation. So instead of vertically keeping the reinforcement, if you keep horizontal means, then you won't get the property. Shape. So if you instead of using cylindrical, if you use square means, due to the sharp corners, fracture will occur easily. So you won't get the proper property on time. So and size, instead of 10 mm, if you use 50 mm rods, so then also you will won't get the property. So these are the five major factors which will decide the property of a composite. So either you manufacture a good composite or a bad composite, these five factors only is going to decide. So what are the fibers? So this also you will be means detailing is seen tomorrow, but just I am giving an introduction. So there are two types of fibers are there. One is advanced man-made fibers, another one is a natural fiber. So means these advanced natural fibers are made by the human beings. Okay, so what to say? Uh, Human beings uh, means okay, the human beings manufacture the fiber means, that is human beings manufacture fibers, that is advanced fiber, man-made fibers, synthetic fibers. If it is available naturally means, that is natural fiber. So what are the fibers which are made by human beings means, best example is glass fiber. So glass fibers they made using melting the molten glass. So they are manufacturing glass fiber. There are different types of glass fibers are there. E glass fiber, S2 glass fiber, R glass fiber, C glass fiber, D glass fiber. So these are the man-made fibers and carbon fibers. So carbon fibers are means this is also one of the advanced man-made fiber only. So they use from the carbon they are manufacturing this fiber. So this is also one of the mostly used fibers, carbon fiber, and this one is carbon fiber. And another one is aramid fibers. This is aramid fibers is Kevlar fiber. So these fibers are used in bulletproof vessels, vest. So the military people will use one vest which is bulletproof. So that material is Kevlar. And also this tires also they are using race car tires. They are using Kevlar. So it means this vest, this Kevlar fiber never allow bullet also. So whatever the speed may be, so this will resist that bullet speed, and this Kevlar fiber is one of the costliest fiber which is used in military applications. And boron fibers. So boron fibers is made from boron. So this material is means circular. See that microstructure they have shown. So earlier tungsten will be there in core, and it is surrounded by a tungsten. So that is boron fibers. So this is one of the ceramic fiber which is made by human. And silicon carbide fiber also there, which is rare fiber, so which is made from a silicon carbide powder. So they will do some chemical deposition method, and they will use this uh, CVD process, and they will make a carbon sorry silicon carbide fiber. And next example is natural fibers. So from silk, so how silk is formed? So from the silkworm, they are taking a silk. So that is a naturally available fiber. When you When you take more, silk will come. So that is silk fiber. Another one is the best example for another natural fiber. This protein fiber is from spider. The spider web is there, no? So that is made of fiber. So that is a spider silk they are saying. So we can take that also as a fiber. And from vegetables, from cotton we can take a cotton fiber. Cotton fiber is nothing but a thread. So the normal thread we are using, no? So that is made of cotton. So that is cotton fiber. And means not these from these plants also we can take fiber. So which is called as a this canaf, canaf or jute or hemp. So like this from plants also we can take the natural fibers, and from banana tree also we can take banana fiber. So like this when we get from nature, natural means, so that is natural fiber. So this is a detailed explanation you can see in the classification of fibers uh, in tomorrow session. So I have given just an introduction. And also the other next thing is shape of the fiber. So the shape of the fiber also will change the property. See, while making composite, each and every point will change your property. So you have to be very careful which material I have to choose, which geometry I have to choose, which how much quantity I should choose, what is the shape I should choose. Everything you have to be very clear while choosing the material. So it may be of circular shape, it may be of alumina, means elliptical, triangle, like the different shapes are there. So the fibers are available in different shapes. So if you change the see, hexagonal, kidney bean, and triangle, so when you change the shape, the property will change. So that is the main thing. Means these are the things which we want to means consider while making the composite. So this application of composites will be detailedly discussed by Mr. Ramesh in session. But now one or two slides I'm showing. So see this aircraft. See the percentage how they. So in the tail they have used glass composite, and this wings they have used aluminium, and this nose part they have used Kevlar composite, and this completely it is made up of carbon composite. So majority of the aircraft is, you see, you can able to see only in the wings only they have used aluminium. Completely that aircraft is made up of composites. This is Tejas aircraft which is used in military. So recent usage, but completely it is made up of composite. That means very less weight and more strength. See this helicopter. See, completely they are using four colors. There are four of composites. The only for the engines they are using metals. All other parts are made up of composites only. Carbon and glass fiber, Kevlar fiber, and carbon fiber. So completely they are using composites. So why I am showing means, so like this only every part, every mechanical. Still we are using late cast iron only. Why not we go for composites? Metal matrix composites. So you know how much that weight is. So like that weight reduction, you can think and you can replace with the composites. See, this is a schematic view of the wing of an aeroplane. Completely, it is different layers are made up of fibers only. Glass fiber, carbon fiber, means steel fiber also there, and skin. Everything is completely made of composite materials. This is a blade of a helicopter. And see this bat rackets, tennis rackets. So that handle is made of different material, that fiber is made of different material. And lightweight vehicles. Earlier days, the weight of the vehicle will be more. Nowadays, if you take sports vehicle, in one hand they will lift and they will port to some other place. And gloves. These gloves are used for high temperature applications. So the heat will not get damage your hand. So the high temperature applications, you can use this gloves. And this is knee pad. So knee pad also they are using carbon composites. And hockey bats, shoes, helmets. You see, when the helmet is made of metal or alloy plates, it will have more weight. Even if you get accident also, it will get means since it is ductile, it will get deformed, and it will not be easy to remove from your head. They will cut using a cutter, then only you can use the helmet. Nowadays they are using this composite helmets. Immediately it will absorb the load and it will get damaged. It will broke into two pieces, so that it is easy